Okay, so today we're going to look at 6.1. So we've done chapter 5, 5.4 to, no, 5.3 to 5.6 and 6.1. These are the sections that are going to be our next test. So our next class period will review, and then we'll take a test after that. So we're getting close to our next test. Now for 6.1, we're talking about inverse functions. So first thing we're going to do is kind of refresh our memory about algebra and inverse functions. So let's call a function f of x. Okay, its inverse we would denote as f inverse. We put that little -1 there to show it's its inverse. It's not an exponent. It's just a notation to say this is a function's inverse. So when we're thinking of inverses, we remember that our domain and range switch places. Okay, so whatever is the inverse, whatever is the domain for f of x is going to be the range for f inverse. So our domain and range switch places. Now, for a function to have an inverse, remember it has to be 1 to 1. So, like x cubed. If I graph x cubed, it's going to look something like, oops, I didn't do that very good. Let's go through the center. It's going to look something like this. It's going to go through the origin. Now, for this to be a function, we talk about passing the vertical line test. Well, it does. It's a function. Now, for its inverse to be a function, it has to pass the horizontal line test, which this one does. So its inverse is a function. So let's see. My domain for this one is all real numbers. So I can plug anything I want into here. My range, notice that it's going to go up forever, it's going to go down forever, is still -infinity to infinity. So if I want to find its inverse, we switch the x and y. We switch the domain and range. So instead of y equals x cubed, I have x equals y cubed. And then we solve for y. So to get rid of this cubed, we take the cubed root of both sides. And that would be my inverse. Now if I graph this, we just switch our x's and y's. So at this point, here I've got the 0.11, so I still have the 0.11. This next point I'd have 2.8, so I'm going to have the 0.82. So it's actually going to look like this. Okay? Now what about if I had just y equals x squared? Now y equals x squared, my graph looks like this. Something like that. Little arrow there. My domain is all real numbers again, but my range is only positive numbers. So on this one, it passes a vertical line test, so it's a function. It does not pass the horizontal line test. So its inverse is not a function unless we restrict our domain. So let's change our domain to say 0 to infinity. So I'm only going to look at this piece. If I'm only looking at this piece, let's regraph that. We're looking at this piece, then its inverse is a function. So we can say, well, y equals x squared. So we switch x and y, and then solve. So I'm going to take the square root. Anytime we do a square root, we put a plus or minus. But in this is why it's not a function. So because when I take the square root of y, I get a positive and a negative for this. Now this one tells us what we're going to choose. So I'm going to choose the positive one. But I don't want the negative, so it's going to be the positive square root of x is my actual inverse. So here, my domain is just positive numbers and my range is positive numbers. Okay, so this is similar to what we're going to be talking about today with trig functions. We're going to find the inverse of trig functions. So let's start with sine. So let's see, so I have y equals sine of x. Okay, so if I graph that, let's kind of graph. Okay, so let's say this is pi and this is 2 pi. Pi 2 pi. These are negative. Make this a 1, a negative 1. Okay, so if we kind of remember, our graph of sine starts at 0, and then we hit a 0 here and a 0 here, and I didn't space these very well. And then halfway between pi over 2 and 3 pi over 2, we'll go to 1 and negative 1. So it's going to look like this, and then it's going to follow the same pattern on this side. Now, this is definitely not a one-to-one function. So we're looking at this, it would not pass the horizontal line test. So we need to restrict our domain. So typically what they've chosen as its standard is looking at just this piece right here. Okay, so we're going to restrict our domain from here to here, which is negative, so negative pi over 2 to pi over 2. Okay, so we're going to just look at just this domain. Okay, so for my inverse, and we either write that as sine to the negative 1, or we write it as arc sine. Okay, those two things say the same thing. It doesn't really matter which one you choose, they both say the same thing. So if I'm going to graph this one, now I know my range here is from negative 1 to 1, so my domain is from negative 1 to 1, and my range is from negative pi over 2 to pi over 2. Okay, so let's graph this. So if I'm looking at this, I'm going from negative 1 to 1. I'm going from pi over 2 to negative pi over 2. It's a negative 1, 1. Okay. Yeah, I'm actually going to say this is 1. And because that's not very, we'll say this is 1/2. Okay. Trying to make it look a little, that's really still not symmetric. Oh well. So at negative 1 here, that's at negative pi over 2. So I've got this point here. At 1 over here, it's at positive pi over 2. And then at 0, I'm at 0. Now, if I look here, if I'm thinking this is pi over 2, let's think about sine around pi over 2. So let's go to pi over 4. Well, let's go, we'll say this is pi over 3, pi over 4, pi over 6. So for pi over 3, sine of pi over 3, you're thinking you're in a circle, that's going to give me 0.8. Well, it's root 3 over 2. So it's about 0.86. This is 1/2, so it's right about here. Then say this is pi over 4, that's about 0.7, it's root 2 over 2. And pi over 6 is down here, like that. Okay, so that's not just a great curve. So it's going to kind of look like this. And then the same thing follows down here. So right here, I'm at 0.8. It's about 0.7. It's about 0.5. So we get about halfway. So our curve actually looks, let's see, I didn't do it very well. It actually looks like this. Let's try that. Y'all know my graphing skills are horrible. Okay. So it looks very similar to this one, except my concavity changes a little bit. Just a little bit. So this one, instead of kind of being more concave up, like this one is, more bowl shape, this is kind of more of an umbrella shape, is what it should be at least. And this is more of a bowl shape. Okay? So my concavity changes just a little bit. So the graph doesn't really change a whole lot, except notice that my my angle values are on my y-axis, and then my points are on my x. So very similar. Okay, so let's look at before I go on to cosine, let's look at, well, what if I wanted to know what is sine inverse? Oh, you can't see that. What is sine inverse of root 3 over 2? Okay, we just kind of talked about it. We said that we're looking for what angle would give me this. So what angle would give me this? If I'm thinking of my unit circle, so we've got 3 here. So sine is 1 here, sine is 0 here. So this one is going to give me 1/2. That's root 2 over 2. Here's root 3 over 2. So it's right here. So that's going to give me at pi over 3. Or if it's wanting it in angles, that's going to be a 60-degree angle. Okay? So really what all this is doing is saying what is the angle when this is my my function value. So for sine, where is sine equal to this is basically what that's asking for. So it's not too bad. So let's look at what does the graph of cosine look like. So let's see, our standard cosine looks like, let's see, 1, 2, let's spread this one out a little bit better. This is pi, this is 2 pi. Now remember, cosine starts at 1. So we're just going to start at 1, at 0 at pi over 2, down at negative 1 at pi, 0 at 3 pi over 2, and back at 1 at 2 pi. Okay, so I have this. Now again, it's not a one-to-one function. So we're going to restrict it. We're going to restrict from here to here. Okay, so we're going to look at from 0 to pi. So my inverse function, which we can write that as arc cosine, is going to be my domain. So my range here is from -1 to 1. So my domain is -1 to 1. And my range is where I restricted it. From 0 to pi. Okay, so another thing, going back to this. Now we talked about our range. We restricted our range for domain, for sine, between negative pi over 2 and pi over 2. So we're looking at this side. So you may have thought a minute ago, well, there's 2 different answers for this because sine's positive would also work right here. Okay, this is also sine of 3 pi over 2. Root 3 over 2. But when we're restricting it, we're only looking from negative pi over 2 to pi over 2. So we're only looking for these values. Okay, so that is why we chose this one. So sorry, I kind of left that out. Okay, so like I said, this one also works, but it doesn't work in the range we're looking for. So this one, we're only looking at the range from 0 to pi. So let's graph it. So if I graph this one, so my domain here, again, let's see, from -1 to 1. My range is from 0 to pi. Okay? Let's slide this over. Okay? So we're looking at this area here. So at -1 here, at -1, we're at pi. So we're going to start here. Let's see, at 0, I'm at pi over 2. And then at 1, my x value is 0. So it's going right here. Okay? So if I think this is pi over 2, so at pi over 4, I'm at 0.7. So it's kind of doing this number here. So it's kind of going like this, and then like this. I'm not going to be super concerned about the concavity there. Again, it's going to kind of have a concave up fill here and concave down fill there. Okay, so cosine's kind of the same thing. So again, if I'm looking for the inverse cosine, we'll say a negative root 2 over 2. for this one, I'm looking at, on my unit circle, it says I'm looking from 0 to pi, so I'm only looking at this area. Okay, so where would it equal negative? Right over here, it would be right here. And so that's going to give me what? That's pi over 3. It's 3 pi over 4, which is the same thing as 135 degrees. So we could say that's either 3 pi over 4 or 135 degrees, depending on how they want their answer listed. So it could be radians, could be degrees. It just kind of depends on what it's really looking for, what the question's looking for. Okay, so let's look at tangent. So tangent's actually easier to draw for its inverse, because typically tangent, we're good about only drawing one piece of tangent, right? Because we have these asymptotes. So I have asymptote here, and tangent typically kind of makes this little number there. All right, so our standard already restricts it for us. So it kind of makes it nice. So here my domain, so let's look at, so my inverse tangent, my domain, my range here is everything. So my domain here is all real numbers. Now, my domain here, I'm restricting it from negative pi over 2 to pi over 2. So my range here is from negative pi over 2 to pi over 2. Now, we make sure you put parentheses because you cannot actually equal those. So if I'm going to graph this one, so I'm going from negative pi over 2, sorry, that's pi over 2, negative pi over 2. And I'm going to have an asymptote here, asymptote here. So here, let's see, whatever this would be. So positive is positive. So positive 1, and that pi over 4, negative pi over 4, and it's just going to look like this. Okay, so these are much easier to draw. Okay, so the other ones I'm just going to kind of draw for you pretty quickly. We've got cotangent, and really just kind of talk about what are the restrictions that we use on these. What are the kind of areas we look for? Okay, for cotangent, we're our asymptotes. They're at pi and 0. So pi and 0. Cosecant or secant, that works with cosine, so we're going to use the same restriction we used for cosine. Secant, we're going to use the same restriction we used for sine. Okay? Okay, so we're using the same one. So cotangent and cosecant use from 0 to pi. And then cosecant are going from negative pi over 2. So for cotangent, what the graph is going to look like, just a quick, simple graph. From pi to 0. Remember, we flip it, it's going to look something like this, because you've got an asymptote here and an asymptote here. Now these are kind of weird, because you're going from 0 to pi, and you've got an asymptote in here, kind of right in the center here, so this is pi. So at 1, we kind of have this number, and then over here at 1, we have this number. So this is at negative 1 and 1. We're kind of fitting around that asymptote. It's really weird, because really what they're doing is they're breaking up, because remember with secant we have these curved pieces. We're actually breaking those up so they fit in the same boundaries that we used for cosine. Sine is the same thing. Like I said, I'm not going to have you graph these a bunch, but just kind of so you can see what they would look like. So this one at 1 is going to do this number, and then here at negative 1 is going to approach. So you've got an asymptote here at 0, and then they're approaching. So again, they're splitting up those U shapes to kind of fit into that. Okay? All right. So let's see, what if I have, speaking of cosecant, what if I want to know what is the inverse secant of negative root 2? Okay, I think my video is about to cut me off, but we'll see how long it'll let me go. So here, this is the same thing, because so the secant of what angle is going to give me negative root 2? So it's the same thing as cosine of what angle is going to give me 1 over root 2. So we could simplify that. It's negative root 2 over 2. Okay, so cosine is between, we said 0 and pi. So if we're looking between 0 and pi, so this little piece here, when does that give me root 2 over 2? We just did that one a minute ago. It's right here. Oh, you can't see it. Right here. This is at 3 pi over 4. Okay? So this would give us 3 pi over 4. So on all of these, we're just kind of going back. Well, what are the angles that give us this sine, cosine, or secant? Okay? So what if I had, let's think calculator for a second, because I know you'll always want to use your calculator. If I had sine inverse of a number that is not on my unit circle, or whatever, what we would do is, if you've got an 83 or 84, you would just do the second sine button and then type in whatever the number is. Okay, so it's pretty easy. Now with secant, cosecant, cotangent, they're a little different. Okay, so say I have this. What you're actually going to do is use the cosine button. So we're going to flip that. We're going to say it's the inverse cosine of 1 over that. So this is what we're actually going to plug into our calculator. We're going to say, we'd say the second cosine button of 1 divided by, and that would give us our answer. So for sine, cosine, tangent, you just do second that button. If you have an Inspire, I think it gives you an option. I think it says arc sine, or it may say sine inverse. But for the 83, 84s, you actually use your second button for those trig functions, and they work just as well. Okay? So what if I wanted, let's go back to our unit circle for a second. What if I wanted the tangent